You know that feeling when you're trying to piece together a puzzle and one unexpected piece suddenly makes a whole section click into place?
Yeah, definitely.
That's kind of what we're aiming for today. We all have that fundamental curiosity about where we come from, those ancient roots.
Absolutely.
Our mission here is to cut through the dense scientific stuff and bring you the most fascinating insights without your brain feeling like it's, well, run a marathon.
Exactly. And today we're holding a particularly intriguing puzzle piece, a fossil pelvis that, despite its age, has some surprisingly modern features to reveal about our early relatives.
Okay, let's jump right in then. We're focusing on a partial pelvis. It's almost 2 million years old, discovered at the Drimolen main quarry in South Africa, cataloged as DNH43.
Right?
Now, a pelvis might not sound immediately thrilling, I get that, but think of it like this. For understanding how our ancestors moved and even gave birth, the pelvis is sort of the foundation of the building.
It really is central, and finding a well-preserved one, especially with associated parts, is rare. So DNH43 is incredibly valuable. What's fascinating here is that this fossil dates back to a really pivotal time in, human evolution. Our goal is to explore what the specific pelvis tells us about these early hominins.
The challenges they faced.
Exactly. The challenges they faced in their environment and how it fits into the bigger, often complex story of our origins. We'll be drawing on recent in-depth analysis of this fossil alongside the original scientific paper.
Published in the South African Journal of Science, right?
That's the one. To guide our exploration.
Okay. Drimolen main quarry, nearly 2 million years ago. That's quite a while back. What exactly did they unearth?
So they found a partial pelvis. This included the sacrum, that's that sort of keystone bone at the base of your spine connecting your upper body to your hips.
Right.
And parts of the right hip bone, or os coxae, as it's called.
And finding those together is the key thing.
Oh, definitely. Finding these associated bones together is really significant. Usually we're working with, isolated fragments. This gives us a much more complete picture of the pelvic structure of this one individual.
And who did this pelvis likely belong to? Could they pin down a species?
Well, we can't say with absolute certainty, but the prevailing theory, based on the more common skull and teeth fossils found right there at Drimolen, is that DNH43 likely belonged to Paranthropus robustus.
Ah, the one with the powerful jaws.
That's the one. Adapted for a diet of tough plants. However, and this is important, fossils of early Homo have also been found at the exact same location.
So it's a bit of an ancient identity mystery. Okay, this recent research you mentioned, what new approaches did they take? What kind of fresh eyes were brought to this old bone?
Yeah, this latest research is pretty groundbreaking because it's the first comprehensive quantitative analysis of DNH43.
Quantitative, meaning measurements.
Exactly. Imagine taking super precise measurements and creating a detailed digital 3D model. This allowed researchers to compare DNH43 using hard numbers against a much larger data set of pelvises, other fossil hominins, modern humans.
So not just looking at it and saying it looks similar.
Precisely. Not just relying on visual comparisons. It's this level of detailed scrutiny that unlocks new insights.
Okay, so they have this digital blueprint. What were the standout anatomical features? Let's start with the sacrum, the base of the spine bit. What did it reveal?
Right, the sacrum, it was noted as being relatively small and having a sort of primitive gracile form.
Gracile, like lightly built.
Yeah, think slender, lightly built. More similar to what we see in older hominins like Australopithecus. And interestingly, the sacral plate, that flattened upper part, was quite narrow from front to back, compressed, you could say.
But there was a real surprise with the sacrum, something that seemed, surprisingly advanced for its age, right? It was maybe the single biggest surprise this pelvis holds about how these early hominins stood and walked.
Exactly, that's the kicker. They measured the sacral tilt, or pelvic incidence, and found it to be around 56 degrees.
Okay, and what does that number mean?
What's truly remarkable is that 56 degrees is almost identical to what we see in modern Homo sapiens, us.
Get out. Really?
Yeah, it suggests that DNH43, and potentially Paranthropus, if it is that genus, had a more advanced spinal alignment than we previously thought possible for hominins living almost 2 million years ago.
Wow.
It implies their torso and head were positioned over their hips much like ours are, which is crucial for efficient upright walking. This really challenges those older ideas that early hominin pelvises lacked the necessary curvature for a fully modern upright stance.
Wow, okay. A nearly 2 million-year-old pelvis with a modern human spinal alignment that's kind of mind-blowing. It completely changes how I picture these early hominins.
It does shift the perspective quite a bit.
So, a primitive-looking sacrum in some ways,
Yep.
but with this very modern tilt. What about the hip bones themselves, the os coxae?
The hip bones were also described as gracile, lightly built. However, the pelvis as a whole was surprisingly wide when viewed from side to side.
Wide?
Yeah, the distance between the hip joints, that's the biacetabular breadth, and also the width at the narrowest point of the birth canal, the bispinous breadth, were both quite large.
Yeah.
It indicates a really spacious pelvic outlet.
A wide birth canal. That sounds significant. What does that imply about how they gave birth? You mean, like, unlike us, the baby didn't have to twist and turn to get out?
Yeah.
That sounds simpler.
That's a good way to think about it, perhaps. This wider outlet hints at the possibility of a non-rotational birth mechanism, similar to what scientists have inferred for Australopithecus.
Right.
In modern humans, the baby has to perform this complex rotation to navigate the birth canal's changing shape. A wider, more consistently open pelvis might have allowed these early hominins to give birth without that complex maneuver.
Interesting. So maybe less complicated births, potentially. But wouldn't a wider pelvis impact their ability to walk efficiently? Isn't there usually a trade-off?
That's a critical question, absolutely. The researchers propose that this broader pelvis might have actually helped these early hominins maintain a decent stride length, even if they had relatively shorter legs compared to later hominins.
Hope so.
Well, the wider pelvis could have facilitated greater rotation of the pelvis itself during walking, compensating for shorter limbs without significantly increasing the energy needed to move around. It's a potential biomechanical solution.
Okay.
They also noted other features consistent with this, like the sacroiliac articulation, the joint between the sacrum and hip bones was relatively small, and other supporting structures were also on the gracile side.
Okay, so we have this fascinating combination of traits, some seemingly older, some surprisingly newer. Which brings us back to that identity question. Paranthropus or early Homo. It sounds like the researchers were really grappling with this.
They were. It's a genuine taxonomic puzzle.
So even with this detailed analysis, we're still not entirely sure if it's Paranthropus or Homo. What are the, one or two key pieces of evidence that could definitively tip the scales one way or the other?
That's the million-dollar question, isn't it? As we've discussed, certain features like that modern pelvic incidence and some aspects of the sacroiliac joint do show similarities to Homo.
Right.
But then you have these other traits, the overall gracile build, the sacral proportions that align more closely with Paranthropus or even earlier Australopithecus.
It's a mosaic.
Exactly, a mosaic. And the researchers emphasize the overlapping time periods and geographic locations of these early hominin groups. It makes it likely they shared some ancestral skeletal features, making clear distinctions difficult.
And what did their detailed measurements and comparisons actually tell them about DNH43's closest relatives in the fossil record? Did the numbers point anywhere specific?
Well, their cluster analysis, based purely on the pelvic measurements, showed that the partial hip bone of DNH43 had its closest statistical links to two other fossils, OH28, which is often classified as Homo cf erectus.
Okay, an early Homo type.
And also to MH2, which is Australopithecus sediba.
Huh. So one Homo and one Australopithecus. That doesn't exactly clear things up.
Not definitively, no. It suggests as a kind of general early hominin pelvic shape. But the researchers are careful, rightly so, to point out that given the variability we see in the postcranial skeletons, the bodies of both Paranthropus and early Homo fossils, these pelvic measurements alone just aren't enough to definitively assign DNH43 to a specific genus.
That makes perfect sense. It's like trying to identify a specific model of car by just looking at, I don't know, a fragment of the chassis or something.
Good analogy.
And you mentioned earlier that Paranthropus robustus is the most common hominin found at Drimolen. So that makes it a reasonable working assumption, maybe? But still just that an assumption.
Precisely. The sheer volume of Paranthropus robustus cranial and dental fossils at the site makes it the most plausible candidate. It's Occam's razor, in a way.
Right.
But the scarcity of well-associated skull and pelvic remains for both Paranthropus and early Homo in South Africa specifically. Well, that creates this ongoing uncertainty.
And it doesn't help that we keep finding new hominins with weird mixes of features.
Exactly. We also have to consider the unique pelvic features found in more recently discovered hominins like Homo naledi and Homo floresiensis, the hobbit. They remind us that Homo-like traits aren't always directly tied to body size or even our direct ancestry. Evolution is bushy, not a straight ladder.
Okay, so this pelvis is offering us valuable clues about how they moved and potentially how they gave birth, even if we can't definitively put a species name tag on it. Let's focus on the locomotion aspect again. That human-like pelvic incident seems crucial.
It really is. That similarity in pelvic incidence strongly suggests that DNH43, and by extension potentially Paranthropus, had a way of standing and walking upright that was mechanically quite similar to us modern humans.
Meaning they had that curve in their lower back.
It implies a more pronounced curve in the lower back. Yes, what's called lumbar lordosis. That curve helps us balance our body weight over our hips efficiently when standing and walking. This is a significant departure from older ideas that early hominins had much straighter, less curved lower spines.
And what about that wide pelvic outlet again? How does that fit into the story of early hominin birth? So the big question is, how do they manage to walk upright efficiently and give birth? What does this pelvis tell us about navigating that sort of impossible balancing act?
Right, the birth question. The exceptionally wide pelvic outlet in DNH43, particularly that bispinous breadth we discussed, definitely raises interesting questions. As we said, it strongly suggests the possibility of a non-rotational birth, more similar perhaps to what's been inferred for Australopithecus.
And that's different from us.
Very different from the complex rotational birth in modern humans. And it's notably wider, for instance, than the relatively narrower pelvises we see in modern human males, which gives us an idea of the constraints a narrower pelvis would impose on childbirth.
This sounds like it ties directly into the obstetric dilemma we often hear about, the evolutionary trade-off between a pelvis shaped for efficient two-legged walking and one wide enough to give birth to babies with increasingly large heads. Think of it like trying to fit a wide object through a narrow opening. Walking upright requires a certain pelvic shape, but giving birth to larger-headed babies needs more space. It's an evolutionary tightrope walk.
That's a perfect description. The obstetric dilemma highlights those competing evolutionary pressures. Bipedalism pulling one way, encephalization growing bigger brains pulling the other.
So how does DNH43 fit in?
Well, DNH43 features this combination of a wide birth canal that didn't seem to compromise its owner's ability to walk upright effectively, thanks perhaps to that modern-like pelvic incidence. It offers us a fascinating glimpse into how early hominins might have navigated this evolutionary balancing act.
So maybe the dilemma wasn't quite so dilemmatic back then.
It suggests that perhaps the constraints of this dilemma weren't as severe in these earlier hominins, or at least in this particular lineage, as they later became in our direct lineage leading to Homo sapiens. Maybe they had found a different solution, at least for a time.
Interesting. Now, one more puzzle piece. Were they able to determine if this individual was male or female? Can you even tell that from a pelvis?
Sexing fossils. That's a notoriously difficult aspect of paleoanthropology. We often rely on differences in pelvic shape between modern human males and females to try and sex fossil specimens.
Like what sort of differences?
Well, for example, the greater sciatic notch, the curve in the hip bone, tends to be wider in modern human females, generally speaking.
Okay, and DNH43?
DNH43's greater sciatic notch does have characteristics that we typically associate with female modern humans. It's quite wide, and its apex, the sort of peak of the curve, is positioned more towards the front.
So likely female then?
Well, here's the big caveat. There's still a lot of uncertainty there, right? Absolutely. Whether those same sexually dimorphic features, those differences between sexes, held true for Paranthropus or early Homo nearly 2 million years ago is still an open question. We can't just assume modern human patterns apply directly.
Right, different species, different times.
Exactly. And interestingly, the researchers noted that other Paranthropus specimens in their comparative sample also tended to show these female-like characteristics in the greater sciatic notch.
Maybe Paranthropus females just had wider notches generally.
Yeah.
Or maybe the differences were less pronounced.
Could be either, or something else entirely. The point is, the researchers caution against definitively assigning a sex based solely on these traits in fossil populations. The patterns of sexual dimorphism might have been quite different in these extinct hominins.
It really underscores that evolution isn't some neat straight line, doesn't it? This pelvis seems to borrow features from different points on the evolutionary tree, It's all mixed up.
Exactly. That's perfectly put. DNH43 beautifully illustrates the mosaic nature of early human evolution. It's not a neat linear progression from primitive to advanced. Instead, we see this intriguing mix of features, some that remind us of more ancient ancestors, like the gracile build, and others that seem to foreshadow later developments in the hominin lineage, like that pelvic tilt.
So these early hominins were clearly a diverse and adaptable group, figuring out how to thrive in their environment, balancing the needs of getting around efficiently and, successfully reproducing.
Precisely. They were navigating a complex world, likely with diverse strategies, and their anatomy reflects the various pressures they faced. This pelvis is a testament to that adaptability.
Okay, wow. We've taken a truly deep dive into DNH43. You had to boil it down. What are the key things you think our listeners should really take away from this specific fossil?
Key takeaways. For me, the most striking thing is that unique combination of traits in this nearly 2 million-year-old pelvis. It shows us a hominin with a spinal alignment for upright walking that was surprisingly similar to our own.
The modern tilt.
The modern tilt, exactly. Coupled with a very wide birth canal suggesting a potentially different, maybe non-rotational way of giving birth compared to us. And of course, the ongoing debate about whether it belonged to Paranthropus or an early Homo really highlights the intricate and sometimes confusing branching nature of early human evolution. It wasn't simple.
Yeah. So this single partial pelvis opens up a whole range of questions and definitely challenges some of our perhaps long-held assumptions about our distant relatives. It's a powerful reminder that the story of human origins is constantly being revised, reevaluated with each new discovery.
Indeed. And it leaves us with a fascinating final thought, maybe.
Right.
How does the existence of such a mosaic creature, exhibiting traits of both earlier and later hominins, challenge our often oversimplified, maybe too linear understanding of human ancestry? What other unexpected combinations of features might still be hidden out there in the fossil record, just waiting to reshape our understanding of ourselves? It certainly encourages us, and hopefully you, to keep exploring paleoanthropology and the ongoing discoveries that continue to illuminate our very deep origins.